Recording. So we know that test 1 is on Wednesday. Thank you, Ty. Now I'm here. And we know test 1 is on Wednesday. It does not include section 6.5. We didn't do that in class. Homework 3 is due, and also the take-home quiz are all due on Wednesday. All right. And again, I want to remind you about that practice set. To definitely be taking a look at that practice set, and the full solutions are posted on Blackboard. Okay, but I think you'll find, let's just say you'll find after you take the test that you should have looked at the practice set. All right, so the practice set is I hope is very helpful. Yes. Yes. Yeah, we are. But before I got into that, I wanted to know if there's anything from the homework that you guys want to bring up first. And I'll devote just a little bit of time to that, just a little bit. And while you're looking, whose is this? Is that yours? Is this yours? Does this look like yours? I'll adjust this. You don't have to hand it back to me. I will adjust your score on Blackboard. Okay. Anything? As in Ferris Bueller's Day Off? Anything? Okay. All right. Then in that case, we are going to cover new material here, section 7.1. And of course, this is stuff that is going to be on the next test. And the entire chapter 7 has to do with integration. So we're continuing to learn more tools in order to integrate expressions. This first tool here, very powerful tool, it's called integration by parts. All right. So it's really based on the product rule. And it allows you to integrate things that otherwise you would not be able to do. All right. The first thing I want to do is to just write down the product rule. Okay, the product rule, as you all know, is that the derivative of f of x times g of x is equal to, well, the first function times the derivative of the second function plus the derivative of the first function times the second function. We all know the product rule, all right? Okay. Now, I'm going to rewrite this a little bit here. I'm going to write this as, let's see, how do I want to do this? I'm just going to switch it around. I'm going to write this as f of x times g prime of x plus f prime of x times g of x equals the derivative of f of x times g of x. I'm just switching the sides. That's all I'm doing there. Okay. Now, what I'm going to do next to get integration into the picture here is I'm going to take since these two things are equal to each other, I'm going to take the antiderivative or integral of both sides. Okay, the antiderivative or integral of each side. All right. So let's do that. So therefore, what we're going to get here on the left side is the integral sign f of x times g prime of x plus f prime of x times g of x dx, I'm doing the integral of the left side, equals the integral of the right side. Now, that's the integral of the derivative of f of x times g of x. Okay, so no big sleight of hand here. The two things equal to each other, we're just taking the antiderivative. Now, first of all, let me just, since we're doing the integral of two things being added together, I can break up that left-hand side integral into two separate integrals, all right? So this left side becomes integral of f of x times g prime of x dx plus the integral of f prime of x g of x dx equals the integral of the derivative of f of x times g of x dx. Right, I just broke up that one integral. All right. Now, this right-hand side, we're taking the integral or antiderivative of a derivative. And so this involves f of x times g of x. What will I get as the result here on the right-hand side that I can, to simplify it? Exactly. Because when we do the antiderivative of a derivative, they cancel each other out. So on the right-hand side here, I just have f of x times g of x. All right. Now on the right-hand side, I still have these two integrals here. So I'm just going to put little marks here rather than just rewrite them again on that particular line. All right. Now what I'm going to do next is just put something from one side to the other here. I'm going to basically subtract this one from both sides, just doing a little algebra, all right? So this is what I would come up with then. The antiderivative of f of x times g prime of x dx, and now that'll be the only thing on the left-hand side. Equals, and then the first thing I'm going to write over on the right-hand side is that f of x times g of x. And then I'm going to subtract off what I have subtracted minus the antiderivative of f prime of x times g of x dx. All right. This is one of the forms for the rule, for the integration by parts that we can use. Right there. Offhand, it doesn't seem like, well, what is this giving me? What we're going to see with the examples that it gives you is that it allows you to simplify something that's in the integral so that you can get the antiderivative. And we'll see when we do examples. Now, I want to write, because when I do integration by parts myself, I don't use this particular formula. It's too long and clunky, okay, for me to use it. This is the formula that I use, and I think will be most helpful for you guys when you do these problems. I'm going to do a little substitution here. Let's call let u be the function f of x. So that's the thing right here. We're going to call that u. All right. And let v, I'll put it over here, let v be the other function, g of x. All right. Now I'm going to take the derivatives of each one of these. So du dx is equal to f prime of x, and dv dx is equal to g prime of x, right? Okay. Now I'm going to do something that we can do in calculus. I don't know how much of this you saw in first semester calculus, but you can actually multiply both sides of these two equations by the dx. You can do that. So this becomes du equals f prime of x times dx. You might have seen this when you looked at the substitution rule. And over here, dv is equal to g prime of x times dx. Okay, now let's start to substitute all these various components into that one thing that I had put a box around. All right, notice here, g prime of x dx, that other remaining part on the left-hand side, that can be replaced by this expression dv, because I have dv equals g prime of x dx. So this is dv. Now let's go on the other side of the equal sign. F is u and g is v. So this part here is u times v. All right. Now let's go on this other integral here. G is the same as v. And f prime, the other part of the integral, f prime of x dx, is the same as du, just by substituting. So let me write this down a little bit neater here. This is the formula that I use. The integral of u dv equals u times v minus the integral of v du. All right. To kind of help me keep my notation straight with this thing, because I need all the help I can get. All right. U and V, U comes before V in the alphabet. U comes before V. U dv is what we start with. We then have the multiplication of the two functions together, and then minus, it's not a plus, and then we do the opposite. Instead of u dv, it's v du for our integral. Okay. Say, well, that's wonderful. Yeah, Kyle.
How would you, I just don't know how you would have gotten the UV minus part.
How I would have gotten the UV?
Yeah, minus, yeah. Would that come from something?
Yeah, it came from right up here. I had written this formula up here. Did you understand how I got to what I put in the big box here?
Yeah.
Okay. Well, the F is the U and the G is the V. So that's why they're getting replaced by U times V. Is that your question? Okay, yeah, I'm just replacing things with different symbols. All right? Okay. Now, let me go to another paper here, and I'm going to write this formula on the top so it sticks around. Integral of U dv equals U times V minus the integral of V du. Okay, so this is what we're going to be working with. All right. So let's see how in the world can this help us. Well, let's do this example. Find the antiderivative of x times the sine of x dx. All right, now if you didn't have integration by parts, you'd be fiddling around with this a lot and getting probably nowhere, all right, with trying to figure out what this integral is. What we have to do is figure out what is going to be u, what will be u, and what will be dv. Because remember, this integral here is integral of u dv. All right. We want things to get better as a result of our choice. So I want to pick, let u equal x. That's right here. So I'm going to put a u here on top of that x. Let u equal x. And the rest of it then has to be dv. That's the whole integral is u dv. So if u is equal to x, then the whole rest of it, dv, is equal to the sine of x dx, like that. Okay. We have to have everything present. Something going on. All right. Now, the thing is, we now have to find v, and we have to find du. Well, du is simple. If u is equal to x, then du, this is just like when you do substitutions, what would du be if u is just equal to x? Dx. Du is equal to dx. So that was easy. Now for v, we've got that dv is equal to the sine of x dx. Let's take the antiderivative of both sides. Antiderivative of dv equals antiderivative of sine x dx. Okay. Now on the left side, the antiderivative of dv, this is really the antiderivative of 1 times dv, is going to be what? What's the antiderivative of 1 dx? What's d? No, the antiderivative is not going to be dv. It's just going to be v. Right. We're just using a different letter of the alphabet, and we're replacing the 1 with a v as antiderivative. Because we all know the antiderivative of 1 dx is equal to x. It's just the same process. All right? And then, so I've got v there on the left-hand side. On the right-hand side, then, I need to get the antiderivative of the sine, and we know that that is, let's see, the minus cosine. All right. So now we've found v. And let's see if this is going to help us. So our integral is equal to u times v minus the integral of v du. Okay, let's fill in the various parts of this. U is equal to x times v is equal to minus cosine of x. So why don't I just put the minus sign out there and write in minus x cosine of x. That's for u times v, right? And then we have minus the integral of v du. So let's copy down what v is, and be careful you don't drop any minus signs in the process. That v is minus cosine of x, and du is just dx from up there. Oops. Why don't I write in dx rather than du? Okay. All right. So look at what we now have. Now for our antiderivative that we have to evaluate, we just have the cosine of x. And we know we can do that. So this is minus x cosine of x. Now I'm going to take into account that I have a double negative, so I'm going to put a plus in its place. And then what's the antiderivative of the cosine? It's the sine, right? Derivative of the sine is the cosine. Plus our capital C. So this is our answer. We were able to get an answer. So what this enabled us to do is enabled us to get rid of this pesky little x that was right in front here and end up in the other integral replacing it with just a 1 or a dx. All right? So we then had another integral that we could use. So that's my first example of this. The trick with this is similar to that thing that I mentioned about using L'Hopital's rule. It's getting the right choice for your u and your dv right at the start. If you mess up on your choice, things will start to get ugly, and you know you're on the wrong track. So it's getting the correct choice at the very beginning. All right. Can I go on then to another example of this? All right. Here we're trying to find the antiderivative of the natural log of x, dx. This is something we have not seen before. Offhand, unless I don't know what it is. But we can hope that we can get something from this integration by parts. Well, in this case, what's the only thing I can select as my u? ln of x. I mean, there isn't a whole lot to pick from here. So let u equal the natural log of x. Now we have to also get du, so we do the derivative of the natural of du is equal to the derivative of the natural log, which is 1 over x. And then we have a dx behind it. Okay. Now, let's see. So this is our u. That means the rest of the integral is our dv. If the whole thing has got to be u dv. So therefore, my dv is just equal to the dx. So therefore, my v is going to be what? Let's see. Do the integral of both sides. And what do I come up with for v then? X. The antiderivative of dx of 1 times dx is x. Right. So we have to do that antiderivative to get the v. We go from dv to v. We have to have all these 4 components, u, du, v, dv, in order to use the formula. So the formula is this. It's u times v minus the antiderivative of v du. All right, so let's see. U is ln of x times v is x, so that's the first part. It's a minus, not a plus, the antiderivative of v du. Well, v, we found out, was x. Du is over here. It's 1 over x times dx. I'm just substituting it back. Okay. Christopher was asking on back right up here, when I got the antiderivative of both sides, should I have put x plus c as my antiderivative? And the answer for this case is no. Just write the x. Don't forget about the plus c right here. No plus c. And for that part of it, for when you're getting the v, when you're going from dv to v, just leave out the plus c. Okay? All right. So here's what we have then. ln of x times x minus the integral of what? X times 1 over x is 1 dx. So, the antiderivative of 1 is x. So our final answer is, let's write it like this, x times the ln of x minus x. And we're done. And you can go and check that. You can take the derivative of that using the product rule, and you'll come back to ln of x. Yeah? Oh, you're right. Now, thank you. Now I put the plus c. Yes, thank you. Anything else? It's a very clever technique. Again, the crucial thing is picking the u and dv correctly initially. All right. Now, here's another example. In this example that I'm going to do right here, we have to apply this rule twice. So sometimes we have to use the integration by parts. Twice. All right? Okay. So let's look at this example. Antiderivative of t squared e to the t dt. All right. Now we have to pick our u, we have to pick our dv, because this whole thing is the integral of u dv. Any ideas of what you might want to pick for the u portion of this. Jenna says t squared, and that's a good choice. All right? So if you went the other way, you'd find out that things got worse, not better. So let u equal t squared. So let's go on and get du right now while we're at it. So du is the derivative of the second 2 times t dt, all right? And therefore, since this part here is our u, the whole rest of our integral is dv. So dv is equal to e to the t dt, the whole rest of it. All right, so we have to find v also. That's part of the process. So I do the antiderivative of both sides. And so the antiderivative of 1 times dv is just v. So I get my v there on the left-hand side. And we know, or hope we're going to know, that the antiderivative of e to the t is just e to the t. It's just equal to itself. Now, I'm not going to put a plus c here. All right, so I've got my u, my v, my du, and my dv. So let's set up our formula here. It's u times v minus the antiderivative of v du. All right, let's fill things in here. U is t squared. V is e to the t. Minus antiderivative. Now v is e to the t, but what is du? UGT. Right up here. Yep. Du is 2 times t dt. So let's mark this in here. 2t dt for our du. All right. So what have we got here? We still have on the right-hand side an antiderivative that we need to do work with one more time. Because I still have, and now instead of having a t squared, I've at least gotten things a little bit better. I just have a t to the first power. All right? So basically, for this one right here, we need to do integration by parts again to figure out what that integral is equal to. Do integration by parts. To figure out this one. So I'm just going to, for right now, let's just put this integral over here, antiderivative of e to the t 2t dt. All right. Now this is what the text does, so I'm going to do it also. Now since I'm doing it, yes, Jenna?
Should we just put like a 1 over 2t in front of the integral so we could cross it out? Like, you know how we do that in normal integration?
Can we just put what over it?
A 1 over 2t in front of the integral.
A 1 over 2t. Can I put right here? Oh, no, I can't bring that. I cannot bring a variable out in front. Okay, is that what you're saying? Can I put it out here, a 1 over 2t outside the integral? No, I can't do that. That's changing things. All right, so again, we have to pick a u and a v. The book uses now capital U and capital V to differ it from the previous u and v. So how about then having my u be, I'll call it a big U, that'll be the 2t. And the rest of it, et times dt, that'll be my dv, capital V. Just using capital letters now. All right. So we've got this now. So we've got u is equal to 2t So derivative du is going to be 2 times dt. Now we've got our dv is equal to, let's see, e to the t dt, just like it was previously. And we do the antiderivative again. So therefore v, capital V, is again equal to e to the t. All right, so let's put this together so we can figure out what this portion of the integral equals. Again, it's going to equal our u times v minus the integral of v du, just using capital letters. All right, our u is 2t from right there. Our v is equal to e to the t, right there, minus the integral. Now this time, we have just e to the t for our v. And then our du is 2 dt from over there. Okay. All right. So we can figure this out now because now we have in our integral just 2 times e to the t. You no longer have a t left hanging in there. So we now have 2t e to the t minus, now I can bring this 2 out front because it's just a constant, minus 2 times the antiderivative of e to the t, and that's just e to the t. Right. Okay, so now we have to go back to our original formula, put it all together, because this was just that second integral that we figured out again using the integration by parts. So let's go back up here. We found out that our integral of t squared e to the t dt, which is what we started out with, well, we had that it was equal to t squared e to the t minus, and then we figured out what that integral was. Okay, let's go down here. Let me put a big parenthesis here. So this integral that we just now figured out was 2t e to the t minus 2 times e to the t. All right. And now we will put the plus c. At the very end is where we put the plus c. Let's go over so everybody can see that. All right. So the only thing left is, well, maybe I can just clean up that right side a little bit because I've got, so it's t squared e to the t. I'm just going to distribute the minus sign, minus 2t e to the t. And then here I've got a double minus, so it's going to be a plus 2 e to the t plus our c. So we had to do it twice, but we have our antiderivative. And again, you can check with the product rule that this will get you back to where we started. Yes? Yes, right here. No. You're thinking of when this is going back a couple weeks ago when we were talking about substitution, and you had something like, let me think of an example here with this. Something like we figured out that, say our integral, I'm blanking on examples. How about, let's see, the cosine, let's just something simple, 2x dx, all right? And so we had our u be the 2x, right, for our substitution. So du was equal to 2 times dx, all right? Now what you're talking about, the way that you had done it in Calc 1 is this. You then multiplied this, put the 2 in here, and then multiplied in front by 1/2 to balance them out. That's what you're talking about, correct? That's how you do substitution. I don't do it that way. I just write out that I just would write out the dx equals 1/2 du and substitute that way. Do you see the difference between that? Because you're multiplying here by a 2 and you're then counteracting it with a 1/2. Over here, if you're bringing out a 2 here, you can't change that 2 into a 1/2, all right? And not unless you want to change the whole problem. Okay? All right. All right. Now the thing is, this can also be used with definite integrals. So there's a formula for definite integrals. So this is it. Again, an antiderivative, but now we put limits, lower limit and upper limit of u dv equals u times v, and then we put our bracket a to b there. So we're putting in our limit minus, not a plus, the integral, again, from a to b of v du. So now we're just putting in our limits into the situation. All right. So I want to do an example here. From 0 to 1 of tan inverse of x dx. All right. Now, we would be hard-pressed also to get this antiderivative. But let's try using the product rule with this. This tan inverse of x, we're going to call the u. And the rest of it, the dx, we're going to call the dv. So we're letting u equal the tan inverse of x. So now we have to get the derivative to get the du. The derivative of the tan inverse of x, something you'll need to know by Wednesday, is 1 over 1 plus x squared times the dx. Okay. Now we have our dv is equal to dx, so we have to go from there to get our v. Again, we do the integral. Integral of dv equals the integral of dx, and we find out that v is equal to x. All right. Now, let's see what happens here with this. Okay, this is going to equal u times v. So what do we have? U is the tan inverse of x. Ooh, tan inverse of x. And then v is equal to times x. So that's our u times v. Let's put in our bracket with our lower and upper limit. And then let me go down here, minus the integral from 0 to 1. Now it's v du. Okay, v is x. Du is 1 over 1 plus x squared. So I can write v du as x over 1 plus x squared. And then, of course, don't forget the dx. Yeah?
We need to change our limits of integration.
For this, we're going, no, for this one, yeah, we will. When we do the last integral. Yeah, we will. But not for here. For here, we're just from 0 to 1. Okay.
Never change that one.
For that one, I don't see why you would need to be changing this one, because it's just the two functions you get. I don't see why that would be necessary for that first part. But let's now go off here. Let's figure out. So let me write this down here. We've got the integral from 0 to 1 of tan inverse of x dx. We found out that it's equal to x. Let me put the x first. X times tan inverse of x. And we're going to do those limits from 0 to 1 minus the integral from 0 to 1 of x over 1 plus x squared dx. All right. Okay. So we've got to figure out this one right here. And we need to use some substitution, basic substitution here. And I'm going to use another letter of the alphabet. I'm just going to use a W. Why not? Let W equal 1 plus x squared, the bottom part. So dW is the 1 goes to 0, the x squared is 2x times dx. All right? So we have an x times dx, so I'm going to multiply both sides by 1/2. And this is how Stewart does the substitution. So x times dx, which I have in my integral, is equal to 1/2 times dw. Now here, if I'm going to change my variable, I need to change my limits of integration, which was just mentioned. When x is equal to 0, what is w going to be equal to? 1. And when x is equal to 1, w is going to be equal to 1 plus 1, or 2. So my new limits of integration then are 1 on the bottom and 2 on the top, only for this integral here. I don't change it for the other parts. And then I'm going to rewrite this as 1/2 dw, and then down here, this is 1 over w. So I'm just doing my substitution here. All right, so we can figure this one out. This is the antiderivative of 1 over w, or like 1 over x. That's going to give us the natural log. So this is minus 1/2 times the natural log of w. I'm going to keep the minus 1/2 in there, from 1 to 2. New limits of integration. All right. Let's go on and figure out what this is. This is minus 1/2 times the ln of 2, and then when I do a double minus, I'm now going to get a plus for the bottom part, 1/2 times the ln of 1. All right. Okay, what's the ln of 1 equal to? This is 0. Now the thing is, don't forget that I also had a limit of integration here, limits for that u and v. So I need to don't forget about that I have this limit right up here. These also to figure out. So this is going to be 1 times the tan inverse of 1 minus 0 times the tan inverse of 0. All right? And then I've got the rest of this here. Okay. 0 times the tan inverse of 0, of course, that's all 0. What angle is the tan inverse of 1 equal to? Pi over 4, right. The tangent of pi over 4 is equal to 1. So this is equal to, here, pi over 4. So let me just write out now my final answer here for this definite integral. For that first part, I just come up with pi over 4. Then for the second part here, this is the only one that sticks around, is minus 1/2 the ln of 2. I will tell you with this integration by parts, you have to be careful with minus signs because you have a minus in the formula. So it is easy, well, you just have to be aware and careful with them, okay? That's what I have to say on that. No, because I already took into account here, let's see, what did I do here? I kept the minus sign in here. Kept the minus sign in here. See, this minus here, Jordan, I kept in there. So it's fine. It should be minus the 1/2. Oh, and and I don't have any plus c because it's a definite integral. All right. Do we have questions on that one? All of this stuff just keeps building on itself. So you've got to get the basics. It's just this entire section, section 7, builds all the way up onto itself. So you've got to get it piece by piece. All right. So let me just, I know our time is almost up here. I'd like to look at maybe one, if I can squeeze this in. I'll look at this one here. This one I think I can get done in. The antiderivative of p to the 5th times the ln of p dp. All right, I think we can squeeze it in. Okay, we're going to use integration by parts. I'm going to let this be my u, because when I do the derivative, I'll get 1/p, which is good. And then this part is going to be my dv, p to the 5th dp. And so this is going to equal u times v minus the antiderivative of v du. Okay, let's get the component parts. U is the ln of p. The derivative du is that 1/p, dp. That's why that was good to select that as my u. My v is the rest of the stuff, dv rather, sorry. P to the 5th times dp, the rest of my integral. I then have to take the antiderivative of both sides. So my v is going to be p to the 6th divided by 6, antiderivative. All right, so let's see what we come up with here. U times v is what? Here's our u, here's our v. So it'll be p to the 6th divided by 6 times the ln of p. That's my u times v. Minus the integral of v du. Okay, what is v? V is p over 6/6. What's my du? Well, right over here is my du. It's 1/p dp. All right, this integral here I can figure out. The p's, one of the p's cancels out. So I have p to the 5/6 dp. And so that's, I can calculate that antiderivative. It's going to be p to the 6 over 6 times 6 over 36 is going to be my antiderivative there. And then up here in front of it, let's write down my u times v. I have p to the 6/6 times the ln of p. And then I put in a plus c at the end of this thing. All right, so this time went fast. After the test on Friday, we'll do a couple more examples and then get on to the next section.
Wednesday.
Huh? No, the test is Wednesday. On Friday, we'll continue a couple of examples of this. I'll be here early on Wednesday.
How early?
Well, I teach from 8 to 9 in this room.
So if we started early, can we start early?
No. Mm-mm. We're not going there to teach.
Slow test take.
Huh? What if you're a slow test taker? Well, you're going to have 2 hours. You're going to be fine. If you're slower than that, then you should be going through another office.
And how many questions is
Oh, there's like, altogether I think there's about 12 questions.
have they asked too much
Yeah, well, that's including A, B, C, and D. It's doable in 2 hours, no problem.
Okay. I covered one teacher, she just had a test that took 2 hours. What?
Yeah, I got somebody typing a message here. My homework on Friday, can I still get late points for this? Okay, just give it to me. Yeah, all right. Okay. Annalie is typing in a message. She better be quick.